Hello everyone, welcome to Adson Engineering Academy. It is me, your tutor Adson, and today we're going to handle a new topic, that is portal frame analysis. So let's look into the method. Well, so this is the question that we have. We have a given frame, and as you can see, the dimensions already given: 3 meter, 3 meter, 3 meter, then 4 meter. Then horizontally, you have 4 meter, 4 meter, 4 meter. So these are very important. Then we have the what? The load applied here. So this is the frame we have to analyze. And before we analyze it, let's look at a possible assumption that we need to take to help us doing this analysis. So in portal method analysis, the first assumption that you have to take that will help you to solve the problem correctly is the point of contraflexure are located at the midsection of all the columns. Okay, you know the columns, definitely the vertical one. Okay, so that means all the center at this point, at this point, at this point of all the columns. Okay, these are called point of what? Contraflexure. So that is what the first assumption is meaning. Then the second assumption says the shear resistance by interior column of a story is twice of that resisted by the exterior what? Column. So this one is very important when especially we are finding the resistance or the shear resistance from the column, okay, or due to the column. Now let's get into the explanation that will help us understand this second what? Assumption very well. If this is what I have as the frame, so definitely I'm having like this. The frame is divided into this format. Okay, so what we're having is that if here is H, the horizontal force, okay, if it is H, then here is also H, the external one. The internal one should be twice H. Okay, so you can break down this. You can say this one is this, then at this point there is what? There is another one like this. Then at this point there is another one what? Like this. So that means this is H, 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 this is H. So you find that here at this point there are two of them, but this one is what? One. That is the explanation for the second what? Assumption. Now with this second assumption, it will help us when we are determining the column what? The column shear. Okay, which is the thing we have to start doing. Now let's determine the column shear. But for us to determine the column shear, that means we need to go story by story. Okay, so let's start with the first one, the first story. So in the first story, what do we have? In the first story, when we consider first story upward, so this is what we have. That means I will have to cut, because the first thing that you're considering story by story, the point of contraflexure should all be marked. Okay, you have to mark all the point of what? Contraflexure, all on these columns. Now after you're done with marking all of them, the first story means we're considering from down here. So what are the forces involved? All these are the forces what? Involved upward. Okay, so that means if these are all the forces involved, what we take into consideration is that I have 1, 2, 3, 4, 5, 6 forces. Okay, so if I have those ones, I will consider with the one which is given. So first of all, I will have 6H. Okay, 6H should be equivalent to the forces, the horizontal forces given. Okay, should be equivalent to the horizontal forces given, which I have 60 plus 60 plus 60 plus 30. Okay, so if that is the case, I'll have to add what? 60 plus 60 plus 60 plus 30. Okay, so you find that the value of H here is going to be, this is what? This is from my calculator, it is 210. 210 divided by 6, the answer is 35 kilonewton. Okay, so that means in the first story, we shall have what? The column shear. Okay, at this point, the column shear. Column means the shear force that will be along this column. It will be what? 35 kilonewton. That is for the external one because it is h. That means in the internal one, as the assumption says, it is twice. So that means A is supposed to be 70, A is supposed to be 70, and A is supposed to be what? 35. The first column is done. Now we have to move to the what? Second story. Okay? So let's move to the second story. I have here second what? Story. So what happens in the second story? The second story means the first story, the 60, because I'm cutting the whole of this frame from here. Okay? So that means this down a 60 will not be considered. So we consider this upper force, this. But remember, all the forces, those other forces that we have, the H, in terms of H, we are considering all of them, those horizontal forces. Okay? So if this is the case, we are considering all this. Okay? This H, this 2H, and then this H. We are considering all of them. These are horizontal forces that we are considering from this aspect. Now, what we have is that we have from what? This 60 upward only, because we are in the second story. So that means we're going to have 6H remains the same, equals to 60 plus 30. Okay? So 60 plus 60 is 120, plus 30 is 150. So when you divide by what? When you divide by H by 6, what do you get? This is 25. So kilonewton. So that means along this what? Along this column in the second story, we shall be having what? H to be what? 25. And then in the middle, that means it is going to be twice. Okay? 50. The external one is 25, while the internal one will be twice. So which is what? 50. So take note of that. Then let's do for third story. For third story, so third story, just the same, this forces remains the same, 6H. Okay? It's going to be equals to, third story means we have to cut the frame from here. So if you cut the frame from here, then we analyze what are the forces here. Okay? So we have 6H, which is from here, and here. Okay? Then we have from 60 upward. So that means it's only 60 plus 30, which is what? 90. So this is going to be equals to 90 kilonewton. So when I divide both side by 6, so you find that I'm going to get what? 15 kilonewton. So just the same way, you need to know that if I cut it from the third story, it's going to be 15 here. So here is 30, then here is what? 15. Then lastly, let's do for what? The fourth story. Okay? Fourth story. So if we are doing for fourth story, we shall in this case consider 6H still, okay, equals to, if I cut, okay, I am cutting the whole frame from here now. So if I cut it from here like this up to here, so I will have H here, 2H here, 2H here, then what? Then H here. So 6H, then the upper force here is only 30, okay? So I will have 6H equals to what? 30. So divide both side by 6, so H will be equals to what? 5 what? Kilonewton. So this is how to find the column shear. Okay? So basically after finding that, you need to represent it on a what? Represent it on the frame. So how do I do that? Okay? So this is how you're supposed to do the representation. We found that this is 5, and we said from the assumption that it's gonna be twice, so this is twice of 5. Just the same way. We found here 15, so you have found that here is twice, then 15. So this is basically how you're supposed to calculate for the column shear. Now, in our next step, you're supposed to what? Learn how to put this column shear into what? In terms of the moment. Okay? So you realize that if I analyze this, okay? If I stand from here and I take only what? I take only this part. Okay? So let me take it. It is vertically. I'm trying to take it what? Horizontally. So I'm here. So this distance, remember there is what? There is a 5 here and there is a 5 here. So from here to here is what I'm analyzing. Okay, if I take this first one, from here to here is what I've drawn here. So I need to know that the distance from here to here is provided in the question. So since the distance is provided in the question and it is given to be 3 meter, okay, to be 3 meter. So that means this is 1.5, this is 1.5. Okay, So that means if I bring this one here, the way I've drawn it, this side is 1.5, this side is 1.5. So understand this clearly. So if this is 5, that means this 5, which is a shear force, if I multiply with this distance from here up to here, the moment at this point, you can get it. So 5 times 1.5 is 7.5. So you draw it like this, then it will go like this. Okay? The same will apply on this because it's on opposite sides. You see that it is a shear what? A shear force of 5. One in opposite direction, one in this direction. So when you multiply this, this will come down in the opposite direction. So just the same way, you have to analyze for each of this beam, each of this column, I mean. So you take this column, you do it like this. But the moment you've done for this, you realize that this is coming to what? 7.5 at this point when you take this force. Then if this is twice, what will be the answer? That means it will be twice of 7.5. Okay? So twice of 7.5, in that case, it's going to be 15. So that means if this is what? 7.5, that means this is going to be what? 15. And this is 15, this is 7.5. So basically, you need to understand how to represent this also on the what? On the bending moment. I can say drawing the bending moment of this because this is a shear force only. Okay? Column shear. So just the same case, you take again what? This column. Okay? This column is having this shear. So the distance is again 1.5, 1.5. So if it's 1.5 and here is 1.5, so for instance, this is going to be 15 times 1.5. So 15 times 1.5, what do you get? Okay? So if that is the case, definitely you'll come to an answer that will help you find all this, because you know that this is 7.5, this is 15. Then this is 22.5. When you multiply 15 times 1.5, 22.5. Then at the middle here, it's going to be twice. Okay? So basically, that is what we call the analysis. You are analyzing. You have got the shear force in the column. Now you have to draw also what? For the bending what? Moment, or for the moment. So I believe you have got clearly how I'm trying to explain this. Take beam by beam. But the moment, the good thing is that if I take this column, I mean, and I analyze it, I see the way the distance is 1.5. Okay? So 5 times 1.5, I get 7.5. Do the same here. 15 times 1.5, I get what? 22.5. Do the same here. 25 times 1.5, what do you get? Okay? You get what? 37.5. Then do the same here. 35 times what? 1.5. So until you find all the what? The answer for that. Now, in this case, let me show you how I have done it. It's here. Okay? The shear force here was what? Was 5. So that's why I got this. The shear force here was 15. So 15 times 1.5 is 22.5. Then the shear force here is 25. 25 times 1.5, you get what? 37.5. Okay? Then the last shear force here is 35. So 35 times 2, remember the distance. The distance of this last one here was what? Was 4. So 4 from the middle here, that means it will be divided into 2. Okay? So that's why here is 35 times 2. That's why we have 70 here. I believe you have understood how to draw what? The column what? Moment in this case. Okay? Yes, so if we're done with the column, let's look at the beam shear. So how do you get the beam shear in this case? The same thing, you have to first start by marking all the point of contraflexure of the beam. So the mid section or the mid span of all the beams. Okay? So this horizontal, remember the horizontal one are the beams, the vertical one are the columns. So we're done with the columns, we are now doing the what? The beam. So you mark all the point of contraflexure. And we're done. So in that case, now what we need to do is to take one by one and analyze it. And to start, we are going to start with the downer one. Okay? So let's take what? This one. So we're taking join. So let's take this particular join, the first join, and we analyze it. Okay? So what is in that join? What we have in that join is, just extend this. Okay. So that join is having this branch, the upper branch, the downer branch, and then this one. Okay? And this one is 60. This one is what? 60? 60. Okay? Now, At this point is where we have the column node. Remember, at the node there is what? Horizontal, and there is what? Vertical. So we have horizontal, and that horizontal we had already found, but you can still find, there is no problem. Okay, you can confirm it. Now what do we have here? This what? In this column we also found it already. Okay, so that means you have to go back to it and check where was that. Then if this is in, you're putting in this direction, that means this down one should be in this other one direction. So let's make a flashback to the column. Okay, so this is our column. So since we are analyzing at this joint, that means we have to consider this one, this 35, and then this 25. Okay, so that means this is going to be 35, and then means this one is going to be what? 25. Remember the nodes for the what? For the column that we did. Okay, so now if this is the case, what we want is to get this vertical what? Shear. Okay, I hope we're trying to follow it clearly, because all in all what we are struggling to is to get what? The beam shear. The horizontal one we already got, no need. So let's get this point. We found that from this what? This beam to the next, from this to the next what? Column, which is what? Vertical here, it was 4 meters for all the three from the question, right? Yeah, from the question, 4 meters. So that means in that case, what we shall have is, where the node is, here will be 2 meters, and here was what? The downer part, here was 4. That means this is going to be what? 2 meters. Then the upper part, here was what? 3. The half of it is going to be what? 1.5. Okay, so let's take what? Let's take the moment at this point, where we're analyzing the joint, at the joint mean. So V times 2 is going to be 2V, and it's anti-clockwise, equals to the clockwise. I have 25 times 1.5. okay, 25 times 1.5, well, and then plus this one, 35 times 2. Okay, 35 times 2. So all in all, if you press this, you come to an answer of V, okay, 53.75 in kilonewton. So that's the value of V. So what is special here is that if you find already from this part, you found already it's what? 53.75 along that line. Okay, along that line, that means I've found for this beam. At this point, I've found the what? The shear. Okay, the beam shear. I've found the beam shear. So this beam shear will be the same as this one, will be the same as this one. So if you have found one, it is the same as this, it is the same as this. So no need to find this and this. So you just move to the next. That is how easy it is. Okay, so let's get to the upper one, the next one. So if I take this one, this part, so I'm having this part where I have 60 is going. Okay, then I have this upper one, then I have the downer one, then I have this one. So this is the beam. I'm taking the beam from here. This is the node. So in this case, I will also have to make my review to what we did already on the column, because I am now what? Here. Okay, so the downer one is 25, then the upper one is what? 15. So the node at the node. So these are the nodes. So the upper one is 15, then the downer one is what? 25. If you choose one direction for this, the upper one should be in the opposite direction. Then this one here is vertical, is what I want. Then the horizontal, no need to get. Okay, because even if you get, you'll get the same. Now the vertical one here is still 2 meters, the way I had shown you. Then here is 1.5. Now here is 1.5. Okay, because we are now at this point where we have 3. So that means if I'm here, half of what? 3 is 1.5. So we are going to take to what? 2 times V is 2V equals to 15 times 1.5. Okay, then this is the plus 25 times 1.5. Yes, so in this case you have to press again, check from your calculator what you're getting. Okay, so according to what I'm finding is that this answer is coming to 60. 60 divided by 2 is 30. So we are finding 30 what? 30 kilonewton. Just the same way I told you, if you found this one is the same as this one, it's the same as this one. Done. So we move to the next one. That is the upper one. We're done with this. Let's move to this joint. Okay. So this joint where we still have 60. This joint where we still have 60. 60 coming in. That means I will have this and this. Okay. And this one. So this is the node for the beam. This one. This node. So at that node I want to find what? V. The vertical one. So you again make a flashback to what you were having. So you're now at what? At this. So up we have what? 5. Then down we have what? 15. Okay. So up we have 5. Then down we have what? 15. 15. So if that is what you have, this is 1.5, this is 1.5. Then this is 2 meter. So this is 2V is equals to 5 times 1.5. Okay. Then plus 15 times 1.5. Okay. Yes. So whatever you're going to get from here should be what? V equals to. So what we have is that this is coming to 30. So 30, then divide by 2, we're getting what? 15. Okay. Yeah. So follow this carefully. Then we have to go to the last one. Yes. So let's do the last one. Hope you have got this clearly. The last one is this part. If I take what? That part where I have 30 is coming in. 30. And then this is going straight to the node that I'm looking for. It's V. Okay. I'm looking for its V. Then down of that 30. What do I have? Down of that 30. Down of that 30. It's 5. From here. From the column that we had already done. Down here. Because we are at this joint. Okay. So being at this joint. So this is what? 5. So I put here 5. Here is 1.5 again. And here is still 2 meter. So 2V is equals to 1.5 times 5. And you know that this is 7.5. 7.5 divided by 2. So V is equals to 3.75. So members, this is how you have to calculate the beam shear. Okay. So you have to represent it on your column. And this is how it looks. As I have told you, calculate for the first one, it's the same for all of them. Calculate for the second one, it's same. Then all this is how we had to do the calculation for the beam shear. Now, the shear force is done. We need to get the moment. Just the same way, if you take this beam, okay, take this beam, here I have a shear force in this direction, 3.75, then I have another one in this direction, 3.75, and up to this point is what I have. So the distance, of course, I know that the distance is 2 meter. So this force times this distance, if I want to get the moment at this point, okay, so that is going to be what? What we have as 3.75 times 2. Okay, 7.5. So that means this part is going to up like this, then this part is going across like this. So this is 7.5, this is 7.5. That is for this beam. And since this is same, so that means all of them, you'll have to what? Sketch them on this. Okay, you have to sketch them like that. All of them will be the same answer. 7.5, 7.5, 7.5, 7.5. Okay, yeah. Now the next part is you have to take again this. Okay. So if you take 15, that one for 15. So 15 times 2. So to get the moment, first time, so this distance, 2 meters. So 15 times 2 is 30. So that means the moment here will be 30. So you draw it like this. So 2 times this, so this is 30, this is 30. Okay. So same, 30, 30, 30, 30. Same for all of them. Do this, 30 times 2. So 60. So you draw through like this, 60, 60, 60, 60. So all this is how to analyze this. And with that, you have to represent it also on a moment diagram. You have to draw its moment diagram. And now the moments diagram is going to look like this. Hope you're able to see as I was trying to explain. You take beam by beam and try to take it, and whatever you have got, it's going to remain the same. So all in all, you have to superimpose all these two. You have to draw it as one diagram for you to have it as a complete analysis. Okay. So this is the complete analysis of that photo frame. Okay. So both the the beam and the column moment have been drawn in one diagram. So that's what you need to do. So you need to analyze this critically. Thanks so much for watching that video till the end. We've come to the end of the question. If you find the video helpful, please like the video, comment, subscribe, share with your friends so that your friends don't miss some of these important topics that I'm sharing.